Good morning, everyone. Welcome to today's session on Introduction to Data Science. I'm Dushyant Kaushik, Assistant Professor at MERI College of Engineering and Technology. Today, we are going to discuss one of the most influential and rapidly evolving field in the modern technology, data science. Over the past decade, data science has transformed industries, businesses, and even our daily lives. From the apps we use, the product we buy, the movies we watch, to the financial transaction we perform, data plays a central role everywhere. This lecture is designed to give you a strong conceptual foundation by helping you understanding what data science is, why it has become so important, when it is applied, and what skill and tools are essential in this domain. Data science is not just a technical subject, it is a way of thinking that allows organization and individual to make informed decision using data rather than assumptions. Throughout the session, we will explore key concepts including type of data, the data science life cycle, statistical reasoning, programming, machine learning, and practical tools. My objective today is to ensure that by the end of this lecture, you develop a clear understanding on how data science function as a bridge between raw data and meaningful insights. Whether you are from a technical background or a non-technical one, data science offers opportunities across multiple disciplines. With this understanding, let us begin our journey into the fascinating world of data science. So, what is data science? So, what exactly is data science? Data science can be defined as an interdisciplinary field that focuses on extracting knowledge, patterns, and actionable insight from data. The term interdisciplinary is very important here because data science is not confined to a single subject or skill set. Instead, it integrates concepts from statistics, mathematics, computer science, and domain experience. Statistics provides methods for analyzing uncertainty and identifying relationships within data. Mathematics support modeling, optimization, and algorithmic thinking. Computer science enables efficient data processing, storage, and computation through programming and software tools. Domain expertise ensure that the analysis is meaningful and relevant to the real world problem being solved. The primary goal of data science is not simply to collect data but to transform data into valuable information that supports decision making. This involves understanding pattern, identifying trends, making prediction, and solving complex problems. For example, data science can help predict customers' behavior, detect fraudulent activities, optimize supply chain, or diagnose medical condition. In simple terms, data science is the science of learning from data. It involves collecting data, clearing it, analyzing it, building it, model it, and interpreting result. It is both analytical and practical in nature. Data science does not only answer questions like what happened, but also why did it happen and what is likely to happen next. This ability to generate insight from data is what makes data science a powerful and transformative discipline in today's data-driven world. So now we will move to next slide. Why has data science become so important today? The answer lies in the exponential growth of data. We live in the digital era where nearly every activity generates data: smartphones, social media platforms, online transaction, sensors, wearable devices, and connected systems continuously produce massive volume of data. This data, often referred to as big data, contains valuable information that can help organizations understand behaviors, predict outcomes, and optimize processes. Traditionally, decisions were often based on intuitions, past experiences, or limited observations. However, in today's competitive environment, relying solely on assumption is risky. Data science enables organizations to adopt a data-driven approach where decisions are supported by evidence and analysis. Businesses use data science to improve efficiency, reduce cost, identify new opportunities, enhance customer experience, and gain competitive advantages. For example, companies analyze customer data to personalize recommendation, banks monitor transaction to detect fraud, and healthcare institutions use patient data to improve treatment outcomes. Data science also plays a critical role in innovation by enabling predictive analysis and intelligent system. It allows organization not only to understand historical data but also to forecast future trends. This predictive capability is extremely valuable in essence. Data science helps transforms raw data into strategic assets. It empowers organizations to move from guesswork to precision, from reactive decision making to proactive planning. As data continue to grow in volume and complexity, the importance of data science will only increase, making it a crucial skill set for the future. Now we will move to the application of data science. Let's now explore where data science is applied. Data science has become an integral part of almost every industry. In healthcare, data science is used for disease prediction, medical imaging, drug discovery, patient monitoring, and personalized medicine. By analyzing patient record and clinical data, healthcare providers can make more accurate diagnosis in treatment decisions. In finance and banking, data science plays a vital role in fraud detection, risk analysis, credit scoring, investment strategies, and algorithmic trading. Financial institutions rely on predictive model to identify suspicious activities and manages risk effectively. In marketing and business, data science helps organizations understand customer behavior, segment markets, forecast sales, optimize pricing strategies, and design a targeted campaign. Recommendation system used by platforms like Amazon and Netflix are classic example of data science. In action, in social media, data science is applied to analyze user engagement, recommend content, detect fake account, and perform sentiments analysis. Cybersecurity relies heavily on data science for anomaly detection, intrusion prevention, and threat intelligence. In e-commerce, data science supports demand forecasting, inventory management, customer analytics, and dynamic pricing. These examples demonstrate that data science is not limited to one domain, it is universal problem solving approach. Its ability to uncover patterns, generate predictions, and optimize decision making makes it valuable across industries. This widespread adoption of data science highlights its transformative power and explains why organizations increasingly invest in data-driven technology and analytics capabilities. Now, we will move to key components of data science. The data science relies on several key components that works together to generate meaningful insights. The first and most fundamental component is data itself. Data serves as the raw material from which knowledge is extracted. Without relevant and quality data, data science cannot produce reliable results. The second component is algorithms. Algorithms are mathematical and computational techniques used to analyze patterns, detect relationships, and build predictive models. These algorithmic form from the analytical engines of data science. The third component is computing power. Modern datasets are often large and complex, requiring significant computational resources for the processing and analysis. Technologies such as cloud computing and parallel processing enable efficient data handling. The fourth component is domain expertise. Data analysis without contextual understanding may lead to incorrect interpretation. Domain knowledge ensures that insights are relevant and practically useful. The fifth component is visualization. Visualization technique helps present finding in a clear and understandable manner. Charts, graphs, and dashboards make complex data accessible to decision makers. Together, these components create complete data science ecosystem. Data provide the input, algorithms perform the analysis, computing power, support scalability, domain expertise, guides interpretation, and visualization communicates results. The effectiveness of data science depends on the balanced integration of all these elements. Now we will study data versus information versus knowledge. Understanding the difference between data, information, and knowledge is essential. Data refers to raw, unprocessed facts and figures without context. Information is data that has been processed and organized to provide meaning. Knowledge represent actionable insight derived from the information. Data science facilitate this transformation process, enabling decision making based on understanding rather than raw numbers. Now we will see types of data. Data can exist in structured, unstructured, semi-structured, quantitative, and qualitative form. Each type requires different handling technique. Data science must understand these variations to apply appropriate analytical method and tools. Next slide is data science life cycle. The data science life cycle provides structured framework for solving data-driven problem, ensuring systematic analysis and reliable outcomes. Now we will move to the next slide, that is data collection. Data collection ensure relevant, accurate, and complete data set necessary for effective analysis. The next slide is about data clearing and preparation. Once data has been collected, the next critical step in the data science processes is data cleaning and preparation. In real-world scenario, raw data is rarely perfect. It often contains missing values, duplicate records, inconsistencies, noise, and formatting errors. If such issues are not addressed, they can significantly affect the accuracy of analysis and predictive models. Therefore, the data cleaning is one of the most important and time-consuming stage in any data science project. This step involves handling missing values by either removing incomplete record or estimating values using statistical technique. It also includes removing noise and irrelevant information that may distort analysis. Data inconsistencies such as incorrect entries or mismatched formats must be corrected to ensure uniformity. Another essential task is data transformation, where data is covered into a suitable format for analysis. For example, categorically data may need encoding and numerical data may require normalization or scaling. Normalization helps bring values within a compatible range, improving model performance. Data prescription ensure that datasets are structured, accurate, and analysis ready. Although this stage may not appear as existing as modeling or visualization, it forms the foundation for reliable result. Clean data leads to accurate insight, while poor quality data results in misleading conclusions. In data science, there is well-known principle garbage in, garbage out. This means that the quality of output depends directly on the quality of input data. Hence, carefully data cleaning is essential for building trustworthy analytical systems.